हेलो स्टूडेंट्स, वेलकम टू फिजिक्स पाठशाला। आज हम पढ़ेंगे कुछ फिजिकल क्वांटिटीज है, इट्स डायमेंशनल फार्मूला। दैट मीन्स we'll find out dimensional formula of certain derived quantities. For example, we have force. Physical formula of force is mass into acceleration. Then dimensional formula of force will be mlt minus 2l1 m to the power 1. This m to the power 1, l to the power 1, t to the power minus 2 is our dimensional formula for force. इसका मतलब कोई भी फिजिकल क्वांटिटी है, इट हैज ए फिजिकल फॉर्मूला और relation with other quantities. This indicates relation with relationship with other quantity. We can say this our physical formula. When it is expressed in terms of fundamental quantities, it is dimensional formula. Fundamental quantities are mass, length, and time. Or when it is expressed in terms of MLT, in that case, this derived quantity is termed as, it is expressed in form of its dimensional formula. Now we can have dimensional formula for a number of physical quantities. The physical quantities are maybe mechanical quantity, it may be thermal quantity, it may be electromagnetic quantity, it may be optical quantities. So we will be able to find out its dimensional formula. Let us have certain physical quantities. Say area. A physical formula is length into length. Then dimensional formula is L to the power 2 m to the 0 t to the power 0. This is dimensional formula of area. Volume V L into L. Then dimensional formula is ml3 t to the power 0. For density, symbol rho, and physical formula is mass upon volume. Then dimension of rho is equal to m l to the power minus 3 t to the power 0. For length, suppose L, it is only 1 L. Symbol is L. Distance L. For distance also we can say symbol may be L or symbol may be S. For that, suppose it is S, then it is L. For speed, distance upon time, S by T. For speed, it is LT minus 1. In that case, M is 0. In velocity, displacement that is displacement by time. Displacement is the shortest distance, hence velocity dimension is again m0 lt minus 1. Escape velocity also is a velocity, it has same dimension. These three have same dimension: speed, velocity, escape velocity. Acceleration is A is equal to v by t. Then dimension of acceleration is equal to m0 lt minus 2. So you can say l to the power 1. Then force is F is equal to m into a, mass into acceleration, or dimension of force is equal to ml t minus 2. Work done is equal to force into displacement, F into S. Magnitude of force and magnitude of displacement. Then in that case, dimension of work is ml2t minus 2. Energy is the amount of work done, amount energy is equal to amount of work done. Hence, energy also has same dimension as work done. Now we have some other physical quantities. Say torque. Torque's moment of force or force into perpendicular distance. Then, if torque is tau, then dimension of torque is equal to mlt minus 2l2. It is same as work done. For power, P work done per time, it will be ml2t minus 3. Momentum is can P m mass into velocity, or m l t minus 1. Impulse force into time, it is J, it is m l t minus 1. Angle theta, no dimension, all parts is 0, m0 l0 t0. It is dimensionless quantity. It is dimensionless quantity. Trigonometric ratios, all sine theta cos theta is again L by L, and their dimension is trigonometric ratio sine theta cos theta or tan theta, or 1 by sine theta is cosec theta, 1 by cos theta is sec theta, 1 by tan theta is cot theta. Their dimension is again no dimension or dimensionless quantity, again m0 l0 t0. Now refractive index mu is again a one ratio by another ratio, hence it is also a dimensionless quantity. Magnification is length by length, again it is a dimensionless quantity. Strain is length by length, change in length by original length, that is length by length, hence strain also is a dimensionless quantity. Stress is force upon area, or MLT. mlt minus 2 ml minus 1. This is same as for pressure. For stress, for pressure, unit is same. That is force upon area, or mlt minus 2 is unit dimension of force by L square, and it becomes ml minus 1 t minus 2. Now we have some another physical quantities. Suppose for modulus of elasticity, that is stress by strain or force upon area by length into length, then it becomes like only for stress dimension is equal to mlt minus 2 then L minus 1. For frequency, mu is equal to 1 by time period or t to the power minus 1. In that case, m will be 0, L will be 0. Angular velocity again theta by t, or which is theta has no dimension, it's again t to the power minus 1. Angular acceleration is omega by t, or it become t to the power minus 2, m to the power 0, L to the power 0. Moment of inertia is mass into radius of gyration square, or ml square, we can say I is equal to mass length to the power 2. Here t is 0. Radius of gyration is the length, it is only 1. Then m0 t0. Surface tension, force per length, then mlt minus 2, then L becomes 0. Gravitational constant is force into distance square by meter square. For force it is mlt minus 2. For distance square it will be 3. For m now minus 1. Surface energy is energy for area, or work done for area. Surface energy is mlt minus 2, then L2 by area, it becomes 0. Angular momentum L is multiplication of moment of inertia and moment of inertia and angular velocity. Like we have normal linear momentum p is equal to mp. Here angular momentum for mass corresponding value is moment of inertia, and for linear velocity corresponding velocity is angular velocity I omega. I already have for moment of inertia ml square, then for omega it is t to the power minus 1. Now we have some other physical quantities like coefficient of viscosity is force into distance by area into velocity. Then will have mlt minus 2, again it is L2 t minus 2, then divided by L2, and velocity is Lt minus 1. For Planck's constant H, will have energy, that is again work done, force into distance. If for force mlt minus 2, for work done ml2 t minus 2, and for equal to, for mu frequency it is 1 by t, or you need to multiply it with t. You can say it is E into t. Then relative density is the density of substance by density of water at 4 degrees centigrade, and it is a ratio of density, hence relative density has no dimension. Velocity gradient is velocity upon distance, that is for velocity is Lt minus 1 by L, that is velocity gradient. Then for pressure gradient, it is pressure, that is force on area mlt minus 2 divided by area L2, and whole divided by again distance L. For force constant, it is, or we say it is spring constant, it is force, dimension of force by dimension of displacement or distance or length. With this, we had 36 physical quantities of mechanical nature, that is mechanical quantities. Now we'll have certain thermal quantities and electrical quantities and magnetic quantities. Now we have some thermal quantities. Heat or enthalpy is energy. Specific heat, heat by mass into temperature. Latent heat, heat by mass. Thermal conductivity is heat into distance by area into temperature into time. Entropy is heat by temperature. Again, it will be energy by temperature. Then universal gas constant is P by NT, or pressure into volume by N is numerical number and T is temperature. Like as you have heat is energy, can say heat or enthalpy has same as work or energy dimension. Specific heat is, again it is heat divided by mass and temperature. We have taken suppose Kelvin, K mine. Now it will be, for energy it is mlt minus 2 L to the power 2, then m is divided by n again by m, then m becomes 0, then k to the power minus 1. K is Kelvin. For, we can say K is taken for temperature. Now for latent heat, it will be heat by mass. Latent heat dimension will be again heat T minus 2 K to the minus 1 and hit by mass, then it will become m0 L2 T minus 2. This is for latent heat. For thermal conductivity, heat into distance traveled by area into temperature into time. Entropy is heat by temperature. You can say again it is energy mLT minus 2 into times K to the power minus 1. We had entropy mL2 T minus 2 K to the power minus 1. Universal gas constant in the case PV by NT. Boltzmann constant, energy by temperature. Stefan's constant is energy by area into time into temperature to the power 4. Solar constant energy by area into time. Mechanical equivalent heat is work done by heat, hence it is a dimensionless quantity or MLT, everything is power 0. Now let us have this dimension of certain electrical quantities. Here electrical charge is Q is equal to current into time IT. In that case it becomes dimension of Q is mL T to the 1, and for current we take A to the power 1. For current it's ampere, for ampere we take A. Now this we need to remember potential. For electric potential or potential difference, it is the work done by charge. Work done we know, work done or energy. Then potential V will have work done by I T. Resistance is again formula V is equal to IR from Ohm's law. R is equal to V by I. Once we know V, you can find the dimension of R. It will be dimension of V by dimension of I. Now for capacitance, capacitance is, we know from the formula Q is equal to Vc or C is equal to Q by P. Inductance is from the formula P is equal to L di by dt or L is equal to V dt. The terms became V times T divided by current I. You can potential into time by current. Now permittivity of space. Permittivity of space is taken from the formula force of attraction between two Charges is 1 by 4 pi epsilon 0 q1 q2 by r square. Now, for relative permittivity is a permittivity of the medium by permittivity of a free space. It is a relative quantity, hence no dimension. It is m0 l0 t to the power 0. Intensity of electric field strength. It is again E is force for charge. Conductance is inverse of 1 by r. Once we know dimension of r, we can find the inverse of r, that is conductance. Resistivity is from the formula r is equal to rho L by A, or rho is equal to r resistance into area by length. Then conductance is inverse of inverse of specific conductance or conductivity. Conductivity is sigma is equal to 1 by resistivity, or we say conductivity is specific conductance. Sigma is equal to 1 by rho, where resistivity was rho or specific resistance. The conductivity is inverse of resistivity. Electric dipole moment is charge into length. Charge into length. Now we have certain magnetic quantities. Number one, magnetic field strength or magnetic field. It is force by q v sine theta, or charge velocity of the charge and sine theta. Then it is now for force mlt minus 2, for q it is 80, for velocity lt minus 1 sine theta, no dimension 1. Magnetic flux is magnetic field times area. Permeability of free space. Permeability of free space is taken from this formula. Force between two parallel current carrying conductors. In that case, the distance between them is d. This distance is between them is d, and the length of the current is taken L. Then force between them will be mu 0 by 2 pi I1 I2. Suppose current here I1, here current I2, length L, and this length is L, and separation is D. Then force is mu 0 by 2 pi I1 I2 L by D. Magnetic moment is current into area. Magnetic strength is magnetic moment divided by magnetic length or length. With this, we had a dimension for mechanical quantities, we had dimension for thermal quantities, we had dimension of electrical quantities, and we had dimension for magnetic quantities, and also optical we have covered.